Now, what's the name of this molecule? What do you mean by it? It's a bond line formula. Here you'll have CH3. This is CH3. This is CH2. And this is CH. And this is a double bond CH2. This is 1-butene. The name of the molecule is 1-butene. Now, this 1-butene, when treated with NBS, it's a brominating agent. So what happens is substitution reaction will take place. So here, this hydrogen here will be replaced by bromine. So we'll get an intermediate compound like this. We'll get a bromine, and we have a single bond and a double bond like this. That is, you'll have CH3 here. Here you have CH. In place of this hydrogen will be replaced by bromine. So, and you have, this is CH and this is CH2. This is an intermediate compound. The next step of the reaction, this is P. And this, when you allow it to react with alcoholic potassium hydroxide, it undergoes dehydrohalogenation. Dehydrohalogenation means removal of hydrogen and halogen. So what happens is this bromine and one of the hydrogen from this carbon, there are 3 hydrogen atoms. One of the hydrogen atom will be eliminated as hydrogen bromide. Now what happens? So you'll have CH2, you'll have a single bond CH, and you have a single bond CH, and you'll have a double bond CH2. But this carbon has only 3 bonds, and this carbon atom also has only 3 bonds. No tetravalency is satisfied. Therefore, a double bond will be formed between these 2 carbons. Therefore, we can write the structure like this. Double bond, that is CH2, double bond CH, single bond CH, and you have a double bond like this. Therefore, the answer for this question is option 1. You should know this reaction. 1 minute. This NBS is called as N-bromosuccinamide. So this is a brominating agent. It's a strong brominating agent. N-bromosuccinamide. The next question, which of the following is wrongly named? The IUPAC nomenclature you should be knowing. Which of the following is wrongly named? Now for this molecule, we have CH3, CH2. These are our previously asked questions. CH2, you have CH, Cl, and COOH. Now, in order to name this molecule, we will first find out the longest carbon continuous chain. And here you can see the substituent also contains a carbon. Therefore, I'll start numbering from my right to the left. Since it is 5 carbon atom, root word is pent. Carbon to carbon single bond, pentane. Since we have a carboxylic acid, remove this E and write OIC acid. It will be pentanoic acid. The parent name will be pentanoic acid. At second position, we have chlorine. Therefore, it will be called as 2-chloropentanoic acid. So this is rightly named 2-chloropentanoic acid. Now, if you take this molecule, CH3, C triple bond C, CH, CH3, and COOH. Again, this has to be given the preference. So the preference will be 1, 2, 3, 4, and 5. Since we have 5 carbon atoms, this becomes like a substituent now. 5 carbon atoms, the longest chain, it's spent. And at third position, we have a double bond. Triple bond we have. So this will be what? Pent -3 YNE. It's a triple bond, pentane. And it's an oic acid. At first carbon, we have acid group, therefore, pent 3-ine oic acid. At second position, we have methyl. So it will be 2-methyl pent 3-ine oic acid. This is wrongly named. This is wrongly named. Therefore, the question is, which of the following is wrongly named? So the answer for this question is 2. We will see the other examples also. Now, if you observe the third example, what they've given it is CH3, CH2, CH, double bond, CH, C double bond O. It's a ketone group. It's a ketone group. And ketone group also has a carbon. It has to be given the least numbering. Therefore, it will be numbered like this: 1, 2, 3, 4, 5, and 6. So therefore, the root word is hex. At third position, we have a double bond. Therefore, hex 3 in double bond. And second position, we have a ketone group. Therefore, it is 2ONE. Hex is known, the parent molecule. So at third position, we have double bond. Therefore, hex 3 in. This is named correct. And here, the fourth option, if you take it, is CH3, CH, CH2, CH2, CHO, and we have a CH3 here. This is an aldehyde group. CHO is a functional group. It's an aldehyde group. It has to be given the preference. So 1, 2, 3, 4, 5. 5 carbon atom. Therefore, the root word is pent. Carbon to carbon single bond. The molecule name has to end with ane, pentane. Since we have an aldehyde group, this E has to be replaced by Al. So it will be pentanal. At third position, we have methyl. Fourth position, we have methyl. Therefore, it will be 4-methyl pentanal. This is also right. So as per the question, which of the following compound is wrongly named? The second compound is wrongly named. So the answer for the second compound is 2-methyl pent-3-ine, 1 oic acid, or you can write oic acid. Either ways, it's 1 oic acid. Better to write the position of the functional group also. The next one, which of the following is monomer of the neoprene? Which of the following is the monomer of a neoprene? Now, isoprene is the monomeric unit in natural rubber. In natural rubber, the monomers are isoprene. Now, in order to understand isoprene, we should know the structure. This is 1,3 butadiene. This is 1,3 butadiene. So at first position, we have a double bond, and also at third position, we have a double bond. Therefore, it will be called as 1,3 butadiene. 4 carbon, 1, 2, 3, 4. In case of isoprene, if the position of hydrogen, the second carbon, is replaced by CH3, we get 2-methyl 1,3 butadiene. This is called as isoprene. This is isoprene. You can see the structure represented here. It's isoprene. The same thing I've written here, isoprene. In order to understand chloroprene, this CH3 will be replaced by Cl. So the monomeric unit in neoprene is chloroprene. These two structures are same. See, in this place CH3, we have Cl. So neoprene is a synthetic rubber. Neoprene is a synthetic rubber, man-made rubber, or rubber prepared in the laboratory. So the monomeric unit in neoprene is chloroprene. So what will be the IUPAC name of this chloroprene? It will be 2-chloro, 1,3 butadiene. This will be the IUPAC name of chloroprene unit. Next, which of the following gives oxygen in water? Which of the following gives oxygen in water? Now you can understand potassium, sodium, rubidium, calcium. These all are metals. Now this is potassium peroxide, this is sodium peroxide, rubidium oxide, and calcium oxide, rubidium dioxide. Which of the following gives oxygen in water? Now, rubidium oxide, RbO2, when this is dissolved in water, we get rubidium hydroxide, RbOH, plus we will get hydrogen peroxide, giving you oxygen gas. So rubidium, when dissolved in water, gives rubidium hydroxide, and we get oxygen gas. Sodium, potassium peroxide, sodium peroxide, and calcium Oxide does not give oxygen when dissolved in water. Rubidium oxide dioxide gives you oxygen in water as per this equation. The next question. Trend of valency in a group will vary. Trends of valency in a group. Now we understand trends of valency. Now for an example, we have lithium, sodium, potassium, cesium, rubidium, francium, all that, cesium, rubidium, all that. So all this will have oxidation number 1. So in a particular group, the combining capacity will not have any variation. It will remain same. Now, for an example, if you take halogen family also, F minus, Cl minus, Br minus, I minus. So you can see the valency is -1 here. Combining capacity, valency is 1 here, not -1, it's 1. It can combine with 1 positive charge. So in the group, there won't be any variation, no variation in the group. In the period, across the period, there may be variation in the valencies, but in the group, valency will not vary, it will remain same. Therefore, the answer for this is option 3. Valency and atomic number, you can see there is no variation, it remains same. The next question. Diborane undergoes cleavage reactions with Lewis base. Diborane undergoes cleavage reaction. Cleavage means breakage with Lewis base to give borane adducts. Adducts means addition products. Adducts means addition products. Now, Lewis base electron pair donors are called as Lewis base. Now, diborane undergoes cleavage reaction with Lewis base to give borane adducts. Now, this is a diborane has a formula B2H6. Now, if we take the Lewis base, hydrogen is not a base. This is a base. Trimethylamine is a base. Carbon monoxide is not a base. But if we take ammonia, which is a Lewis base, electron pair donor, what happens is it will react to give one of the hydrogen. See, diborane, we can represent this as a BH3 and BH3. Borane has a formula BH3 and it exists as a dimer. So therefore, it's called as diborane. So what happens is one of the hydrogen will be replaced by ammonia. So we get from this BH2, in brackets, we will write NH3. And you will have a positive character. And this hydrogen will be accepted by this group. Therefore, we will have BH4 minus. This is called as addition product. Addition product. So adduct, it's called. Therefore, the answer for this question is it is ammonia. So diborane reacts with ammonia to give addition products. Now, in which case the maximum energy is needed in the formation of monopositive gaseous ion? In which case energy is needed to form monopositive gaseous ion? Now, if you can observe that carefully, we understand that lithium, sodium, potassium, rubidium, rubidium, all belong to first group. Alkali metals. Alkali metals. We understand as we go down the group, atomic size increases. As we go down the group, atomic size increases. As atomic size increases, ionization energy decreases. What is ionization energy? Ionization energy is energy required to remove an outermost electron of an isolated gaseous atom. What is ionization energy? Energy required to remove an electron from the outermost orbit of an isolated gaseous atom. Isolated gaseous atom. Gaseous atom. Now, what we understand from the series is lithium is smaller compared to sodium. Sodium is smaller compared to potassium, and potassium is smaller compared to rubidium. Because I clearly told as we go down, the group atomic size increases. Now, in order to remove an electron from the outermost orbit, it is easy for rubidium because rubidium is larger. When the size of rubidium is larger, the outermost electron will have less interaction with the nucleus because nucleus is positive, electron is negative. But in case of lithium, it is smaller in size, therefore the nucleus and electron will have more affinity. Since this nucleus and electron will have more affinity, what will happen is to remove this electron, the energy required will be very high. So the interaction between nucleus and electron will be more when the size is small. And here, there will be less affinity between nucleus and electron. Therefore, to knock the electron from rubidium, the energy required will be less. I hope you are following. So therefore, the question, we'll read the question again and answer. In which case, the maximum energy is needed in the formation of monopositive gaseous. Lithium ion giving you electron. Sodium gives you one electron and becomes sodium ion. Likewise, potassium and rubidium. And lithium is smaller in size. It has very high ionization energy. Therefore, the energy required will be maximum for lithium atoms so that it can form monopositive, one positive gaseous ion. So answer for this question is option 1. The next question, select the most acidic species. Select the most acidic species. Now, H3PO2, these are our oxy acids of phosphorus. H3PO2, H3PO3, and H3PO4. H2PO2 is stronger acid compared to H3PO3, and H3PO3 is stronger than H3PO4. There's phosphorus acid. Phosphorus acid is a weak acid. So the strength of the acid here, H3PO2, is stronger compared to H3PO3, and that is stronger compared to H3PO4. So the most acidic species here is H3PO2. The next question. Which of the following is not hygroscopic? Which of the following is not hygroscopic? What do you mean by hygroscopic? Now, magnesium chloride, calcium chloride, lithium chloride, when exposed to air, it starts melting. It becomes like a viscous solution. That property is called as what? Hygroscopic property. But when we talk about NaCl, this NaCl is a common salt, which is used in cooking. And this common salt, if you would have observed, if you keep it for how many ever months exposed to air, it will not become like a liquid, or it does not become viscous. The solid remains the same. So sodium chloride is not hygroscopic. And all the other magnesium chloride, calcium chloride, lithium chloride will be hygroscopic. If at all, if you're seen in your labs, when you're doing the salt analysis, when the attendants open the bottle, in the bottle, you would see some of the salt becomes like a solution. They would say it is decomposed. They would say it is because of the nature of those salt, which is hygroscopic. So the question here is, which is not hygroscopic? So the answer for this is sodium chloride. The next question, which one of the following do not impart color to the flame? Now, sodium chloride gives golden yellow flame. Sodium gives golden yellow. Metals gives color to the flame. Sodium gives golden yellow. Barium gives apple green. Strontium gives, I think it's crimson red color. Magnesium will not give any color. Why magnesium will not give any color? See, color of a substance is because of excitation of electrons from lower level to higher level. But in case of magnesium chloride, magnesium has very high ionization energy. So magnesium, in magnesium chloride, magnesium will be already in Mg2 plus state. So from this, if the electron to be removed, the energy required will be very high. Therefore, magnesium does not impart any color. All the other salts impart color. Which one of the following does not impart color to the flame? The answer for this question is option 1. Magnesium chloride does not give color. The next one, incorrect matches. Blister copper is 98% impure. Concentration of bauxite is by leaching. Silver, noble metal, is extracted by MacArthur cyanide process. It is called as hydrometallurgy. Nickel is purified by Mons process. This is correct. Silver, gold is extracted by hydrometallurgy. This is also correct. Bauxite is concentrated by leaching, Bayer's process. Now, blister copper. Blister copper is 98% pure. The option they have given is 98% impure. In a hurry, we overlook this. All right. So you should carefully take time to read the options. They asked incorrect match. Blister copper is 98% impure. It is an incorrect match. Therefore, this is the right answer for this question because blister copper is 98% pure. Which have lowest carbon content? Lowest carbon content. Iron, wrought iron, pig iron, and chrome steel. Which has the least carbon content? Amongst this, extraction of iron, we have learned in that we know that it is around less than 2% of carbon present in wrought iron. Therefore, the least percentage of carbon is present in wrought iron. The 84th question, Ln stands for lanthanum, lanthanide. Lanthanide on hydrolysis gives LnOH thrice plus X. What is this X they're asking? Now, we understand that lanthanum's stable oxidation state is +3. When this is allowed to react with 3 water molecules, so water we can write 3OH and 3H. So what happens? We get lanthanum hydroxide, giving you hydrogen. 3 hydrogen is not possible. So you need to balance the equation. 2 and 6. So you get 2 moles of this and 3 moles of this. So hydrogen gas is liberated. X is hydrogen. Therefore, the answer for this question is option 3. The correct hybridization of, see, this question, this is all memory based. Xenon hexafluoride, noble gas compound, xenon tetrafluoride, carbon dioxide, xenon tetraoxide. The hybridization of the molecule here. In case of xenon hexafluoride, it is sp3d3. Xenon in tetrafluoride, it is sp3d2. Carbon dioxide is sp. And xenon tetroxide, it is sp3 hybridization. Therefore, the answer for this question is option D. So this is part B question. As I told you, part B, you will be given 15 questions and you'll have to write 10. Yesterday, I was discussing this. So in part A, 35 questions, you'll have to answer all 35 questions. In part B, for NEET, you have choice. The same paper, 15 questions, or that you have to write 10. The following formula are given for Van 't Hoff factor from Which of these formula Van't factor cannot be calculated? From which of this formula Van't factor cannot be calculated? Now, see all this, these all are colligative properties. Now, see, this is like not this. Pi V is equal to nRT, we have learned. This is osmotic pressure. Or we know that pi is equal to N by V RT. Or we can write pi is equal to C into RT. Now, from this, Van't factor cannot be calculated. So I stands for Van't factor. So here, this formula, using this osmotic pressure of this formula, we cannot calculate Van't factor. In all other, we can calculate Van't factor. I can be calculated using freezing point, using boiling point, using Raoult's law, relative lowering of the pressure. But here, in case of osmotic pressure, using this formula, it is not possible for us to calculate the Van't factor. Hence, the answer is option 1. Following formula are given for Van't factor I, from which of these formula Van't factor cannot be calculated? We cannot calculate from osmotic pressure method. See, this is thinking question. 2 moles of an ideal gas. The next question, 2 moles of an ideal gas are expanded isothermally, reversibly, from 1 liter to 10 liters at 300 Kelvin. The enthalpy change in kilojoules for the process is. They're asking enthalpy change. See, if it is work done, we can calculate it's minus 2.303 nRT log of V2 by V1, or we can write W is equal to minus expansion, it is minus. Compression, work is done on the system, therefore W becomes positive. Expansion, work is done by the system, therefore you write minus sign. So 2.303 nRT log of P2 by P1 in terms of pressure. But here they've given volume. The question is not asking us to calculate the work done. They're asking the enthalpy change in kilojoules for this process. You should remember, for isothermal, iso means same, thermal stands for heat, temperature, and reversible process. For an isothermal and reversible process, internal energy delta U or delta E is 0. Likewise, delta H is also 0. Change in enthalpy for isothermal process is 0. Hence, the answer for this question is option 3. You should not try to keep calculating the work done and confusing. All right, so they're asking enthalpy. If they were asked work done, you can use this formula, and then you can use this formula and calculate. But question is not based on work, it is based on enthalpy change. Enthalpy change for isothermal and reversible process is always 0. Not only enthalpy, internal energy is also 0. Change in internal energy is also 0. Hence, the answer is option 3. The next question. When 9.65 coulomb of charge is passed through a solution of silver nitrate at atomic weight of silver nitrate is 1. Atomic weight of silver it is. Atomic weight of silver. It is not mentioned. Atomic weight of silver is 108. The amount of silver deposited. This is based on Faraday's law. 1 Faraday gives 1 gram equivalent weight. Now, the equivalent weight of silver is 108 divided by 1. Valence of silver is plus 1. So 108. So 1 Faraday is 96,500 coulombs. 96,500 coulombs will give 108 grams of silver. So, but they've given you 9.65 coulombs. Gives you how much? It will be 9.65 into 108 divided by 96,500. On simplifying, we will get, it is marked, it should be A, B, C, D, E. All right. So you can simplify this. The answer we will be getting is 0.0 0.0108 grams. That will be written as 10.8 milligrams. You can see the answers they've given in milligrams. If it is in grams, it is 0.010 gram. Since they're given in milligrams, so you have to convert this into milligrams. It's 10.8 milligrams. So I have not used any formula here. So we can also use formula and calculate. That is, weight of substance deposited can be calculated by the formula equivalent mass ZIT, right? Or Z into the equivalent mass by 96,500 into current. Current what we're passing, 9.5 coulomb into Faraday. Faraday is 96,500. All right, IT, sorry. Time they have not mentioned here. Right, so I don't think so we can use this formula to calculate this, because we know Faraday's first law, W is proportional to the charge. W is proportional to I into T, or W is equal to Z into I into T. There is T here. Time they have not mentioned here in the question, so we cannot use this formula. So you use this and understand to work out. This is 10.8 milligrams. The next question. For a reaction PCl5 giving you PCl3 and Cl2, the forward reaction at constant temperature is favored by. Forward reaction at constant temperature is favored by. See, PCl5 giving you PCl3 and Cl2. They all are in gaseous state. Introducing inert gas as constant volume. Introducing chlorine gas at constant volume. See, if you introduce chlorine gas at constant volume, reversible reaction will take place. Reversible reaction will take place. So this will favor reversible reaction. Introducing an inert gas at constant pressure, increasing the pressure of the system. Introducing PCl5. See, introducing PCl5, as the concentration of reactant increases, the forward reaction favors. This is right. Introducing inert gas. When you introduce inert gas do not react. But the number of moles increases on the reactant. Therefore, it also will favor the forward reaction, constant to volume. Hence, the answer for this question is option 2. The not option 2. It is option 1, and it should be option 1 and 5. Let's see, is there any option? It should be option 1 and 5. It is not 3. It should be option 1 and 5. This is the right answer. Introducing PCl5 and introducing inert gas at constant volume. Option is somewhere to check it. The next question. Calculate the spin-only magnetic moment of Cr2 plus, chromium 2 plus, chromium 2 plus. Firstly, we will take chromium. Chromium atomic number is 24. The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and 3d5. This is the right configuration for chromium. 4s2, 3d4, people write it is not wrong. Due to stability, we get 4s1, 3d5. Since they've given chromium 2 plus, 2 electrons has to be lost. 1 electron from 4s and 1 electron from 3d. Therefore, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, and you will have 3d4. You'll have 3d4. Now, if you take D sub, oh, sorry, excuse me. Something wrong. So if you take D subshell has 5 orbitals. 1, 2, 3, 4, 5. We have 4 electrons. We can write 4 electrons like this. This is 4 unpaired electrons. So N is 4. Magnetic moment is calculated by the formula square root of N into N plus 2. That is square root of 4 into 4 plus 2. So it will be root of 24. That will be around 4.90. Bohr magneton. The unit is Bohr magneton. Hence, the answer for this question is option 2. The next question. On complete combustion of 0.5 grams of organic compound, 0.22 grams of carbon dioxide at thing, it should be combustion of carbon dioxide and gives you water. It's 2O obtained. H2O. It's not H2O. H2O obtained. The percentage of carbon and hydrogen respectively. The percentage of carbon and hydrogen respectively. Percentage of hydrogen is 4 and percentage of carbon in this case is 12. Just give me one moment in time. It is a direct question. It is based on the formula in the first POC topic. So please refer that formula and remember that formula. The next question. What is the absolute configuration of a given compound? What is the absolute configuration of the given compound? The compound is missing here. Compound is missing here. So we cannot answer this question for now because the compound is missing. The next question, 95 point, not 95, it's 90, this is the 93rd question. 5 centimeter cube of acetone is added to 100 centimeter cube of water. The vapor pressure of water over the solution will be equal to the vapor pressure of water, less than the vapor pressure of pure water, greater than the vapor pressure of pure water, very large. Acetone will, when acetone, 5 centimeter cube of acetone is added in water, acetone plus water is a non-ideal solution showing positive deviation. Therefore, the vapor pressure will be greater than the vapor pressure of pure water. The answer is option 3. The mole fraction of a solute in 1 molar solution is 1 molar aqueous solutions. The mole fraction of water of a solute in 1 molar aqueous solutions. I've given the answer to be 3, but we cannot calculate the mole fraction. Mole fraction is calculated by the formula number of moles of a particular component divided by total number of moles. When we say total number of moles, it is number of moles of solute plus number of moles of solvent. Surely we know the mole fraction, number of moles of solvent. Solvent is water. Water. 1 molar aqueous solution. This is 1 kg. 1 kg is 1000 divided by 18. It will be 55.5 moles. So molar solution as a number of moles of water we know, solvent, but we don't know the solute because it's not mentioned what's the solute. Therefore, we are not able to answer this question, but the solution, it's 0.27. It's mentioned. The next question. Which of the following is correct about photochemical smog? Photochemical smog is formed through photochemical reaction involving solar energy. Photochemical smog is an oxidizing agent. Its main component is PAN, peroxyacetyl nitrile, all the above. So it's all the above. The answer for this question is all the above. The right answer. The next one. Consider CuCl2 minus coordination number is 6, NiCO4 coordination. No, they're asking proper matching. They're asking us to match this properly. So for nickel, coordination number is 4. So it is, maybe we will do it like this. 2-chlorinate coordination number. So for A, it is 1. It is 4. B, nickel, it is 3. because monodentate ligand, 4 monodentate ligand, coordination number is 4. For platinum, C, it is again, it should be 3. It's again 3 because 4 chlorine atom, it is 3. And for nickel, it is 6. That is D, it is 6. The answer will be this. So here also 1, 2, 3, 4. So there is no compound with coordination number 5. So for both, the answer is this. So answer for this question is option 3. Assertion. A, boric acid is a weak acid. Boric acid is a weak acid, yes. Boric acid receives OH minus ion from water and H plus ions of water is released. So boric acid, that is H3BO3, H3BO3, we can write as HBOH thrice, H3BO3. This boric acid in water, H2O, we can write H and OH, gives you BOH 4 times minus, and we get H plus. Therefore, the answer for this is 1. Both assertion and reason are true, and R is the correct explanation. Boric acid receives OH from water, and H plus ion is released as per the reaction. Therefore, the answer is right. The next one. In the below reaction, instead of magnesium carbonate, magnesium hydroxide is precipitated because of MgHCO3, magnesium bicarbonate from heating gives magnesium hydroxide and liberating carbon dioxide gas. High solubility of magnesium bicarbonate, low solubility of magnesium bicarbonate, low solubility of magnesium hydroxide, high thermal because of the low solubility of magnesium hydroxide. So on heating magnesium bicarbonate, we get magnesium hydroxide. The lattice energy order, AgF greater than AgCl greater than AgBr greater than AgI. Reason, AgF is more soluble. Both assertion and reason are true, and the reason is correct explanation of the assertion. Both assertion and reason are true, but reason is not correct. If assertion is true, but the reason is false. This is not the right reason. AgF is not more soluble in water. So therefore, the answer for this question is option 3. The next question, how many statements among the following is are correct? Wilkinson catalyst used for hydrogenation of alkene. Very right. Estimation of calcium magnesium ion can be done on the basis of stability constant of formation. This is complex symmetric titration. This is also correct. Complex containing chelating ligands generally have smaller value of instability constant than complex containing monodentate ligand. So complex containing chelating ligands are highly stable. They have smaller instability constant. Therefore, this is also right. Toxic proportion of copper and iron are removed by chelating ligands, dipenzylamine and diferoxyamine, B via the formation of coordination compound. This also right. So therefore, the answer for this question is option 4. So we've done with this one test paper. A lot of questions we have learned. We'll continue the next test paper in the next class. Ma'am, I'll stop the class, ma'am.